Hey guys, in this video we will be going over how to solve quadratic equations by factoring. First, let's talk about what a quadratic equation is. A quadratic equation is one that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. This form is considered the standard form of a quadratic equation. And some examples of quadratic equations are the following. The first equation is written in standard form. And with a little bit of simplifying and rearranging, these can eventually be written in standard form. Quadratic equations are also called second-degree equations because the highest power on the variable is 2. And there are many different ways to solve a quadratic equation. And normally when we solve a linear equation with a degree of 1, like x plus 5 equals 7, we would have to isolate the x on one side. However, this will be difficult to do with the higher degree equations, like x squared plus 5x plus 6 equals 0. We won't be able to isolate the x variable here. We will have to use a different method instead, and one way is by making use of factoring and the zero factor property. So this property tells us that if we have two factors, say a and b, and if a times b equals 0, then either a is equal to 0 or b is equal to 0 for this to be true. This can also extend to more than two factors, but the same idea would apply. So let's see how we apply this property with an example. So for this example, we want to solve the following equation. And recall that to solve an equation, we must find the value or values of x that will make the equation true. We can use the zero property to solve this. So in order for this equation to be true, then either the factor x minus 3 must be 0, or the factor x plus 1 must be 0. Thus, we will set both factors equal to 0 and solve for x. If we solve these two linear equations, we have x equals 3 and x equals -1. So let's check this. If we substitute 3 in for x, we get 0 times 4, which equals 0. So this is true. And if we substitute -1 into the equation, we get -4 times 0, which is also equal to 0. So this is also true. Therefore, 3 and -1 are both solutions of the quadratic equation. For the next example, again, in order for this equation to be true, either this factor must be 0 or this factor must be 0. So by the zero factor property, we can set each factor equal to 0 and solve for x. X equals 5 for the first equation, and x equals -7/2 for the second equation. Therefore, 5 and -7/2 are both solutions of the quadratic equation. So as a side note, it's very helpful when the quadratic equation that we have to solve is factored on one side and equal to 0 on the other side. So only use the zero factor property when the product is equal to 0. For example, if you have a quadratic equation like x times 2x minus 7 equals 4, do not set each factor equal to 4. To solve this, one side must be 0, so we would have to solve this a different way, which we will talk about later. Okay, so for the next example, notice how the left side is not factored. In order to use the zero factor property, this side will first need to be written as factors. The first step is always to see if there's a GCF that can be factored out. These terms have a GCF of 3x. So let's factor this out. The next step would be to check if you can factor anything else further. This factor is actually a difference of 2 squares, since we can rewrite it as x squared minus 2 squared. So we can factor this using the following formula, where a is x and b is 2. Now we have the left side fully factored and can apply the zero factor property. We set all three factors equal to 0 and solve for x. Thus, the quadratic equation has three solutions for x: 0, -2, and 2. For the next example, notice that the quadratic equation is written in standard form. However, in order to solve this using the zero factor property, we must first factor this side. So since the coefficient of x squared is 1, we can take the shortcut approach to factor this. So we set up factors with x written first, and we are looking for two numbers that multiply to -40 and add to -6. So ignore the negative for now and list out factors of 40. Those numbers should be 4 and 10 after we adjust the signs, making 10 negative. So double check to see if this multiplies to -40 and adds to -6. It does, so these are the two numbers for the second term of our factors. Now this side is written in factored form, and we can solve this using the zero factor property. So set both factors equal to 0 and solve for x. And our solution set is -4 and 10. So sometimes a quadratic equation will need to be written in standard form first before we can factor. So for the next example, notice that the quadratic equation is not written in standard form, so we begin by writing it in standard form by subtracting 20 from both sides. And now that the equation is in standard form, we will factor this side. So we can't take the shortcut approach with this since the coefficient of x squared is not 1. We'll have to use our factor by grouping method, but first we will need 4 terms. To find what we split 3x as, we need to find two numbers that multiply to 2 times -20, so -40, and add to 3. Those numbers should be 5 and 8 after we adjust the signs, making 5 negative. Double check to see if this multiplies to -40 and adds to 3. It does, so these are the two numbers that we will use to rewrite 3x. So we can rewrite the equation as 2x squared minus 5x plus 8x minus 20 equals 0. And now we have 4 terms. We can split this into 2 groups and factor out the GCF from each group. Then we can factor out the common binomial. And now our factored form is 2x minus 5 times x plus 4. Now we can apply the zero factor property and set each factor equal to 0 and solve for x. So our solutions for x are 5/2 and -4. For the next example, again, notice that the quadratic equation is not in standard form. To do so, we add 42x to both sides. Now that we have it in standard form, we will factor this side. It looks like these terms have a GCF of 6x, so we will factor this out first. So it looks like we cannot factor these any further. So now let's apply the zero factor property and set both factors equal to 0 and solve for x. So our two solutions are 0 and -7. And for this example, although the left side is factored, we cannot apply the zero factor property here because this product is not equal to 0. Therefore, we will need to multiply this out and then rewrite our equation so that it is in standard form, so we subtract 5 from both sides. Now our equation is in standard form, and we will factor this. The coefficient for x squared is 1, so we can apply the shortcut method and find two numbers that multiply to 27 and add to -12. Those numbers will be 3 and 9 after we adjust the signs to negative for both of them. Double check to see if this multiplies to +27 and adds to -12. And it does, so these are the two numbers for the second term of our factors. Now we can apply the zero factor property and set both factors equal to 0 and solve for x. And our solutions are 9 and 3.